The goal of this video is to discuss some common misconceptions that people have about evolution. So we'll talk about evolution as a theory, we'll discuss how it relates to thermodynamics, and we'll talk about some observations and transitional fossils that support the theory of evolution, and then finally we'll address some common misconceptions about how evolution really works. By the end of this video, you should be able to refute some common misconceptions that people have about evolution, and you should be able to describe how this process works on populations. So one of the most common misconceptions about evolution is that it's just a theory because there's not a lot of evidence out there to support it. However, keep in mind that you've already learned about some scientific theories in this class, like the cell theory. So a scientific theory is really a comprehensive explanation that's supported by lots and lots of evidence. So theory doesn't mean that we're not sure about it. Theory actually implies that there's a great deal of evidence supporting it. So scientific theories are logical, they're useful, and they're based on extensive observation and evidence. So there are lots of theories out there that we talk about in this class. So the cell theory and the atomic theory are other examples. So just because evolution is a theory doesn't mean that it's uncertain. Second, another common misconception is that evolution violates the second law of thermodynamics. So as you remember from earlier in this course, we talked about the second law, which states that in the universe or in an isolated system, the degree of disorder must increase. So entropy increases. However, one thing to keep in mind that even though organisms are ordered systems, they actually do increase the entropy of the universe. So you have to think of a cell as an ordered system that's constantly releasing heat and releasing waste that actually increase the disorder of the environment around the cell. So even as things are becoming more organized, this is actually leading to an increase in the disorder of the universe. So therefore, evolution does not, in fact, violate the second law of thermodynamics. Another common misconception is that evolution has never been observed. This is in fact not the case. So there are many examples where scientists have in fact observed evolution. And here's a nice example. So here we have the yellow monkey flower. So this is an example of the plant. And if you treat a population of these plants with copper and then select those plants that are resistant to copper, that actually generates a new species. And we know that because when copper-sensitive plants are crossed with those that are resistant, the hybrid offspring are inviable, indicating that we have developed a new species that's not capable of interbreeding and producing viable offspring. So there are lots of other examples of this, but a common one that we see every day, that cancer cells develop resistance to chemotherapeutic drugs. So this is an example of evolution that occurs over the process of treating a cancer cell. So many times cancers will recur even after treatment because they've developed resistance to a specific drug, and that's because the population of cancer cells has evolved to become resistant. Another common misconception about evolution is that there are no transitional fossils. In fact, a fossil has been found that is consistent with the transition from fins to limbs. So here you can see a tetrapod. This fossil is approximately 365 million years old, and this fossil is consistent with the transition in the humerus that occurred between fins and the humerus that we see today. So here's the limb that we see today. So there is also evidence in the fossil record that supports evolution as well. Another common misconception is that evolution proceeds by random chance. So there is a part of this that is in fact true because mutations do happen at random. So we know that we're constantly exposed to mutagens in our environment that cause mutations in the DNA, and some of these do in fact become incorporated into the genome, and these do provide genetic variation. We've also talked about some other sources of genetic variation, such as independent assortment and also meiotic recombination. However, it is natural selection and not chance that decides which mutations are actually kept within a population. So you can imagine here, before selection, we have a variation in color in this population. So these mutations that cause different colors have happened at random. After selection, we've selected for only a subset of the cells in this population, leading to a final population that's all red here. So if this were in terms of resistance, you can imagine that we've selected for a population of cells that has high resistance to a chemotherapeutic drug. So in fact, even though the mutations are random, the natural selection is what determines which mutations are actually kept within a population. So evolution actually proceeds as a result of natural selection. And finally, the last misconception, and probably one of the most common misconceptions I see in my students, is that evolution works on individuals. In fact, evolution only works on populations of organisms. So we have to have a large population of organisms with lots of genetic variability. Here we can see in this population of ladybugs, we have lots and lots of genetic variability in the number of spots, anything from 0 to 6 or more spots. So this population, you can imagine that natural selection could select for individuals with a certain number of spots. However, it can only act on the population, not on a single individual, because any individual ladybug is not going to change its number of spots based on natural selection. Natural selection can only act on the population. And that concludes this video.